Welcome to Chapter 3. So Chapter 3 is all about solving systems of linear equations. In the first section, we're going to talk about how to solve them graphically. So our learning target for the day, again, we're going to learn how to solve linear systems with a graph. So when you have two or more related unknowns, you may be able to represent their relationships with a system of equations, which all that means is a set of two or more equations. And a solution of a system is a set of values for the variable that makes all of the equations true. So again, method one for finding this is graphically, okay? So when I graph the 2 points, where the lines cross, that is a common point for them. So that's a point that is true for both equations. So let me show you how this works. So for example, for this first one, I'm going to do this in red. Remember, whenever you're graphing lines, you want to start up at the y-intercept, so at the positive 4, and now slope of 3/2. Up 3 over 2. Up 3 over 2. Then I'm going to do the same thing in the reverse. In this chapter, it is critical whenever you're graphing lines, make sure you extend the slope as far as it can go, okay? Because if you don't, and you don't graph it accurately, your point of intersection also won't be accurate. I'm going to draw this one in blue. So this time starting down at the intercept of -4 and slope of -1/2. Down 1 over 2. Down 1 over 2, so on and so forth. And what we're looking for is that intersection point right there. That is where both equations are true. So my solution is going to be that written as a point. Okay, so my point solution is -4, -2. That's the x and y that is true for these equations. And of course, I can do that for the next one as well. So to graph the first one, start at the y-intercept of -2, and then slope of 1/2, up 1 over 2, up 1 over 2, so on and so forth. And then I'm going to do this in reverse also. I want as many points as possible to keep this as straight as possible. And my second one, starting up at 5, and then slope of -3. So that's 3 over 1. So down 3 over 1, down 3 over 1, and of course, so on and so forth. And connect them up. And if you graph it carefully, you will see the intersection point right there. And that point, this time at x of 2, y of -1, that is what I'm looking for. That is your solution. Now, of course, we're going to get things that are slightly different than that, okay? So remember, the best way to graph is y equals mx plus b form. So what we want to do is always make sure that we get it in y equals mx plus b form. So what that means for this first one means I need to add that x over. Okay? As now y is by itself, and I can graph that line. Start with my y-intercept of +1, slope of 1 over 1, so up 1 over 1, and I get my line. And of course, as always, extend as far as you can to keep your line as straight as possible. For my second one, this is going to be 2 steps to get the y by itself. I need to subtract the x and divide by 3. And once I've done that, now I'm ready to graph. Start at the y-intercept at positive 5, and now I have a slope of negative 1/3. So down 1 over 3, down 1 over 3, so on and so forth, and again, extend it in both directions. And my goal, I want that common point. I want that point of intersection as my solution. And this time it looks like it is at 3, 4. All right, looking at our next one. Top equation, to get y by itself, I'm going to add the x over. And now y is already by itself. So I'm going to start at that negative 2, slope of 1 over 1. So up 1 over 1, up 1 over 1, so on and so forth. And for my second equation, for my second one, I need to subtract the 2x over. So I start up at 4, then I have a slope of negative 2 over 1. So down 2 over 1, down 2 over 1, so on and so forth. And draw my line. And of course, here, be careful when while you're drawing it, but you should see the intersection right at the green. And that is going to be at 2, 0. All right. Now, the really cool thing is, if you ever want to make sure you have the right answer, you can always plug those values in. So notice here, negative 2 plus 0 does equal negative 2. 2 times 2 plus 0 does equal 4. So if you ever want, you can actually go and you can double check your answer. You can make sure that the point actually works in those equations. All right, now there are two that we want to be very careful about. Okay, so parallel lines that never touch, they are going to have no solution. While coinciding lines, so two of the same line, they have infinitely many solutions. So these are two situations that we want to watch out for. And let me show you what they look like. So top one, I'm just going to graph. So start up with a y-intercept of 1, slope of 2/3, up 2 over 3, up 2 over 3, so on and so forth. Bottom line, I start down at negative 5, and then same slope, up 2 over 3, up 2 over 3. Now notice what's happening because they have the same slope. These two lines, oh, sorry, I was getting a little bit off track. These two lines are never going to touch. They're never going to cross to have a point of intersection. So that's why this is the case of no solution. Because the lines never cross, there will never be a solution. All right, so you may be wondering about the next case. All right, well, to graph it, of course, we need to get y by itself. So I'm going to subtract 2x and divide by 3. All right, so start up at the y-intercept, slope of negative 2/3, so down 2 over 3, down 2 over 3, so on and so forth. Then my blue line, subtract 4x, divide by 6. Well, negative 4/6 would reduce to negative 2/3. 12 divided by 6 gives me 2. So this is an interesting situation where notice same y-intercept and same slope. So when both aspects are the same, when you're literally looking at two of the same equation, you get two lines that touch infinitely many times, okay? So this is that case when they are literally on top of each other, when they are the same line. This is infinitely many solutions. Every point that they touch at is a solution because they share every single point. So just two things to watch out for to make sure you understand our special cases. All right, so word problem. You and your best friend have lemonade stands and decide to start a competition. You've already made $30 and make about $5 per day. So if we're tracking your money, you make $5 per day and you already have $30. Your friend already has $21 and they make $8 a day. And what you want to know is how many days will you have the same amount of money? So, in other words, when are these lines going to cross? When are they going to touch? So, we need to graph these. Now, obviously look at how high our y-intercepts are. So, we're probably not going to want to count by ones because we're never going to make it, okay? So here, I'm going to count instead by threes. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33, 36, 39, 40. Oh, I'm sorry, not 40. 42, 45, 48, 51, 50, not 53. Wow, I'm really messing this up this time. 51, 54. Okay, and then obviously here, we're just going to count by ones. So, for the first one, okay, the first one, we have a y-intercept up at 30. Okay, y-intercept up at 30, and we need to count by fives. All right, so up 5, so that'll put me at 35 over 1. Up 5 more, so up to 40 over 1. Up 5 again, so up to 45 over 1. Okay, so there is my blue line, the first one. The other one starts at 21, so starts down here and goes up by 8. All right, so if I go up 8 over 1, that'll put me up at 29. Up 8 over 1, so 29 plus 8 would give me 29 plus 8, 37. 37 plus 8 will give me 35. So, by graphing those, and again, this one is a little bit tricky simply because our numbers aren't as easy to scale, but I think you can see where they are crossing, okay? After 3 days, you're both going to have $45, okay? So even though the graphing is a little bit more difficult, the process is still exactly the same. Now, branching off from that is sometimes it's easiest if we can use technology. Okay, so I do want to show you how you can use technology to check your work. Like, for example, let's say that word problem. Let's say it's just we're not getting the right answer. Well, we can use technology to help us. Okay, so here on the calculator, I've already shown you how to graph lines, right? So what I want to show you is you can graph two lines at the same time. 2x minus 3, here, 1 half, oh, 1 half x, and that should be a minus 4. I'm sorry for that typo. And we want to see where do they cross. Oops. I'm sorry, I left a feature on from a previous thing, so let me fix this really quickly. There we go. Graph. And if we want to know where these cross, there's a really cool feature under calc. So if you go above trace into that calc feature, there's this really cool thing called intersect. All right? And intersect will actually find that intersection for you. So it's a really, really cool tool. So if you go into intersect, it'll ask you for your first curve. You're going to want to be to the left of your intersection point. So since this is my intersection point, I want to be to the left of it. Hit enter. Second curve, you want to be anywhere to the right of the intersection point. And then it will actually calculate it for you. So my intersection is at negative 0.6 repeating, negative 4.3 repeating, and it can actually find the intersection for you. So again, that's a really cool feature to know that you can graph it and then intersect on the calculator. That's a really good way to check your work to make sure that you are in fact doing it right. So a lot of cool stuff in this video for you to explore. So I do want you to take a moment, write that summary for me, reflect on some of the things that we talked about, and then come back ready to do your practice work.